Hi there, my name is Joe Gardiner. I'm a solutions architect working at Pure Storage in the office of the CTO across the EMEA region. Thanks for joining my session today. So let's start with a quick look back at Kubernetes adoption data. So as you can see, this comes from the CNCF survey in 2020. And we can see this massive jump in terms of organizations going into production from March 2016. But also data around the applications that are being built for and deployed in containers and Kubernetes. But I think it's particularly interesting. So two data points from Gardiner jump out at me on this slide. The first being that most organizations are working with multiple cloud providers. And I think they're normally weighted towards one, but I'll talk a bit about that later on. But also, the fact that the vast majority of organizations will be running containers in production by 2025. And as we can see, a lot are already doing that. So really, it's absolutely the case that Kubernetes and containerization are the new standard for deploying applications. And I think that if we look at some of the challenges around containerization, what's particularly interesting for me, if we focus in on the technical challenges, and not to gloss over complexity or cultural changes being challenges, because they absolutely are. But I think they're challenges with any new wave of technology. If we look at config management and cloud and so on, I think complexity and cultural challenges persist. But I think if we look at security, it's commonly the top technical challenge. But the fact that storage is now in second place, I think really just shows the maturing use of Kubernetes, and also I think the changing applications in terms of the kind of workloads that are being deployed in Kubernetes. I think that's changing, and we're seeing with those changing workloads new challenges around data management and storage. And to link that back to really what I see happening in organizations, I mean, we've seen containers used as part of application refactoring efforts, but also really just to make applications more portable. And if we look at how that applies to an organization, most that I engage with or have spoken to over the last year or so have some kind of application modernization program, or maybe platform modernization. But ultimately, they're looking at their existing application landscape. They're looking at how they are building new applications, and they're using Kubernetes-based platforms to do things like reduce infrastructure requirements, licensing requirements, gain greater agility, expose parts of their applications to partners, and essentially deliver better value for their customers, whether internal or external. And the thinking around these programs is normally like this in terms of the percentage of the applications that are being modernized. And to give you some anecdotal evidence here, that there was an organization I worked with, a bank in the UK, who had a target to move sort of 80% of their application landscape into Kubernetes by sort of 2023, 2024, something like that. And this is kind of what their plan looked like. And unfortunately, the reality is a little bit more like this, where we see this kind of initial surge around stateless applications that are relatively easy to containerize and move into Kubernetes. But then we see this kind of next wave of workloads that are non-critical stateful applications. So that means really development workloads. In this case, we actually had a virtual cache machine, or an ATM, that was used to write new firmware, right? And these will be containerized, but use often sort of existing storage solutions, which are suitable for these kind of non-critical workloads. But where things start getting tough is when you start looking at increasingly critical and complex applications, whether they're legacy apps that are being containerized, or modern applications that you're building, maybe around AI or ML. You've got data pipelines. Either way, there's complexity and criticality, and that's where things start to slow down. And the reason that projects will often get blocked at this point is because tough questions get asked. And there are a few challenges here. I mean, absolutely, trying to provide storage to a highly dynamic, agile, disaggregated compute platform using storage systems that were designed for ultimately virtual workloads is going to have its challenges, especially when you get to scale. But also those storage services are often fragmented, and that means that you end up trying to account for numerous ways of interacting with these storage systems. Even though there's a standard, you're still getting a different experience for the user, product experience from that storage system, which makes it very difficult to provide any kind of consistent data management solution up to your containerized applications. But I think even more important than that is the fact that as the criticality increases, the attention from leadership in an organization also will increase. And this is where difficult questions get asked. For example, how can we, you saw the majority of people have multi-cloud. So how can we now move our workloads between multiple cloud environments? Yeah, we know we can do it with containers. How does it work for our data? Or perhaps, we're in a multi-tenant environment. We've got massive density. We're sharing a storage backend. How can we protect data when we have all of these users sharing a common infrastructure environment? Increasingly, backup and recovery is becoming a priority, again, due to the maturity of the use cases. How can we make sure we're meeting our SLAs? Maybe we're providing an application service to consumers and that we have SLAs around that, or internal targets. But also, maybe we're building Kubernetes as a service as an internal platform for our development teams. How can we provide an SLA around that? And it's very difficult to answer these questions with the traditional infrastructure-centric approach from the storage layer. But I think we have an excellent blueprint. And that is Kubernetes. We know how to build distributed, highly scalable, orchestrated platforms. And if we look at what it is about Kubernetes, the characteristics of Kubernetes, these ones really stand out for me. The fact that it's infrastructure agnostic, it's providing a common control plane, no matter what the underlying infrastructure is. Kubernetes is going to pool compute resources, whether it's virtual servers, physical servers, Raspberry Pis, Intel NUCs, it doesn't matter, right? And that's powerful. It gives you flexibility as an IT organization. I think that common control plane is powerful for developers. The fact that you can build your pipelines against a common set of APIs means that you're going to cut down on complexity and improve the velocity with which you can release code and application releases. But also scale is a huge thing. I mean, we can achieve huge density, and you need a platform that can cope with that density and scale to thousands of nodes and thousands of pods. The fact that it's extendable, you can swap in and out various infrastructure components, but also you can write custom resources within the frameworks that are provided. So you still get that consistency, even though you're customizing components. But I think most importantly is the fact that Kubernetes is ultimately application centric. The whole point of Kubernetes is that it gives us this self-healing, highly scalable platform onto which we can consistently deploy our applications. So if we take that blueprint, if we take those design principles and we apply it to storage, what does that look like? Well, I strongly believe it should follow the same design patterns, and it should be infrastructure agnostic. It should run on top of any storage system. It should be able to operate at massive scale. Just like Kubernetes, you shouldn't hit object limits or be slowed down by your storage, right? Your storage should be as agile as your compute platform. So when you scale up, your storage scales up. That it should be a native part of Kubernetes. You shouldn't have to learn or interact with the storage system directly. You don't do that for servers, right? So why should you do it for storage? And I think ultimately it should be application centric. And it's hard to really fully appreciate what that means. But for me, application-centric storage and data management means it understands things like topology. It can understand different categories or class of application. Is it a relational database? Is it an in-memory database? Is it a streaming application? Is it a content management system? But ultimately, and I'll expand on this in a moment, for me, it's important that a storage system understands the importance of consistency between the applications consuming that storage and the storage itself. And that's really important when we look at some of the use cases for Kubernetes. And I think this is a great one from the Portworx perspective. If I look at what that means for me in my world and where I sit from the kind of vendor perspective on this, is that a real kind of rising requirement across my patch, across EMEA, is this need for disaster recovery. And I'm not talking about taking it back up and restoring somewhere else. I mean, yes, that's a form of disaster recovery, but I'm talking about metro style, land style DR. And here, we know how to do this. We've been doing this sort of data replication for these sorts of environments for a long time at the storage level. But the problem is that a traditional storage system isn't going to understand anything about applications. So yes, you can replicate the data, but when it comes to failing over, if you have very large numbers of pods, it's very difficult to then go back and redeploy those workloads and mount the correct volumes in a seamless way. And there's often manual intervention required, or an investment in Ansible script or something like that. Essentially, it's not feasible. And I think that with the Portworx approach, which does follow that blueprint that I've been describing to you, it's been designed to keep application resources in sync and maintain that link and treat applications and data as this kind of single object. And what that means is that when there is that failure event and you flick the switch to fail over, there's this relationship between the compute orchestration layer and the data orchestration layer. And the applications come back and immediately mount the correct volumes with really just one API call. And so that capability is so powerful, but it's actually what customers are now asking for. That maybe not exactly in those terms, but they're hitting challenges that can be solved by this kind of approach to data management within the Kubernetes environment. So I just want to leave you with some of my sort of experiences from the last year engaging with Kubernetes users, various sizes and various maturity. So you saw at the start that lots of organizations are running across multi-cloud. And as I said, it's often a single cloud that is the main cloud. But I think that multi-cluster and multi-cloud is actually going to become mainstream this year, just from the conversations I've been having. And that brings with it a whole range of challenges around portability. And also things like resource use. A data platform should be able to scale and not spike CPU and RAM use when it does that, right? And that's particularly critical in cloud. And so I think that's going to become a hot topic. Equally, edge, especially in retail, I have lots of conversations around logistics, delivery, stores actually as well, and how organizations are really looking at decentralizing IT, but still maintaining hubs where data is collected and also distributed from. And they're looking at containers, of course, offer the portability to allow that kind of pattern, but storage is a challenge there. So I think that will definitely be something that becomes increasingly important for retail, along with many other organizations, manufacturing and so on. I'm finding that my conversations are shifting away from specific use cases where we're talking about building a development platform for multiple Jenkins or GitLabs, or building an Elasticsearch as a service for a bank, for example. And now they're becoming more strategic, meaning that there is absolutely acknowledgement that container storage does need to be looked at as part of the strategic decision making at the Kubernetes level, and that they go hand in hand. And so more of my conversations now are much more around not individual use cases, but more of a platform strategy kind of discussion. And finally, I think slightly obtuse final point here, but I think that we're going to see a shift away from necessarily a focus on provisioning as part of a Kubernetes interaction, and more as an application interaction, meaning that right now we might think about, well, how are we deploying applications? We need to make sure storage is in place. We need to configure it a certain way to make sure we're meeting our SLAs and so forth. But I think really the focus is going to shift to, I want to deploy a clustered database, and everything underneath that really should align with that requirement, whether it's networking, whether it's compute, whether it's storage. And there shouldn't really have to be afterthoughts around how that should be configured. That needs to be really encapsulated and provided as a service. And I see that demand starting to emerge. So I think this is an early stage point, but I just wanted to put it in because I think we'll see these kind of conversations evolve over the next couple of years. Of course, if you want to learn any more about any of the things that I've touched on today, check out portworx.com. And you can also read more about some of the use cases there in our customer base that I've also been describing. So thank you very much for joining.